So now we're talking about visibility and embedded expertise. So this is the bridge from the physical to logical activity. Let me show you the dashboard for TS7700. We have 8 dashboards available in TS7700. Capabilities are very similar to the disk product. As you can see, the first 5 dashboards, the first 3 dashboards are rated green, so there's no issue as far as cache, virtual drives, or throughput. But we are seeing issues with utilization, with replication, with the back end. And then migration and recall are no issue for this particular environment. I'd like to show you a dividing point between the first 5 dashboards, or the first 5 reports, and the last 3. At TS77 environment, we'll always have the first 5 dashboards, but the TS7740 with a tape back end will only have the last 3. So that's kind of a little method to our madness in terms of the organization of the dashboards on this particular chart. But the first place we have is a problem with utilization, so I want to show this to you. Looking at utilization, we look at first at the grid level. If you had multiple grids, we'd be showing multiple rows. But in this particular situation, there's one TS7700 grid, and it's having a problem with CPU percent in terms of CPU utilization. So if I do the drill down, I'll go from here to clusters. Now I'm looking at a variety of clusters, and I see I've got 2 clusters within the grid. And again, both clusters are having an issue with the CPU utilization. Now, if I were to click on the cluster 0, for example, it'd show me the time charts. But for the purposes of demonstration, I want to change the order a little bit and actually look at the detail in CPU 0, give you a little characteristic of what's going on there. I also want to change my view so that I can maximize the chart. So now you're seeing a maximized chart. Let me go into that. Hopefully you can see that I am showing a maximum value now that when it peaks, it hits 98%. And the time of the maximum value is going to be at 3:15 a.m. We have a 98th percentile of 95%, 95th percentile of 92%, and the average is at 58%. So, and this gives you an idea of the specific readings we have at all the variety of different intervals. Now, we don't have any particular information concerning maximum or the average disk utilization, and the reason for that is that this particular TS7700 is a microcode level 2.1, and those fields are not being reported, so it's not of any great concern. Let me back up one now. CPU utilization, let me show the chart. Change it back to time charts. We'll assign the mini chart. This is the chart for CPU utilization. As you can see, we've got a lot of white space involved. The thresholds are only exceeded at certain peaks and points in time. And a lot of times with tape activity, if you're looking at a midnight to midnight, it'll look bimodal. You know, it'll start high, basically go down during the day, and then come back up in the evening. The secret to trying to get CPU utilization up is certainly whatever I can schedule and move into the white space. Otherwise, I'm looking at a processor upgrade in order to be able to handle the peaks that I'm seeing. One of the things that actually gets involved when I'm using CPU is, and things I can schedule, at least in the TS7700, is something called reclamation. So I want to look at that for a second. I go back to a normal size chart, and we'll go to the back end, and we'll look at what kind of reclamation is going on with this particular cluster. And as you can see, these are all the different back-end performance charts. But if I'm looking at reclamation, this is the physical reclamation mounts. We're not doing any reclamation in this particular point in time, so this is a bust in terms of trying to find a problem, or at least something I can schedule out of the way in terms of CPU utilization. Reclamation is not going to fix the problem. So going back to utilization again, I want to show you a little bit about some of the detail. We also have the ability, rather than to go drill down from the dashboards, you also can go straight into the reports. Here's TS7700 system, and if I look at system, I'll see that, yeah, here's my CPU utilization. And these are all the various different peaks and valleys, but this is without the, this is for the grid. And if I drill down further, I'll have both grids, or both clusters within the grid, and then if I come here, if I go to identify, isolate, I'll see this particular grid. So this is the same chart you saw earlier. One of the things that correlates very highly with CPU utilization is the throughput, the cache throughput. So I actually bothered to create a graph that maps both variables together. And here's the red line is the total CPU utilization percent, and here's the total rate of all cache throughput going on within the cluster itself. And as you can see, these are two variables are very highly correlated. So whenever there's activity going on in the cache, that's when the CPU is going to get busy, and that makes sense. So if I go and I actually look at the cache rate, which is another graph I have available from the system view, I can look down on the clusters, click on the cluster, and I can look at the cache flow that's going on within the cluster. This tells me all the variety of different activities that are going on within the cluster itself. And what I see is virtual device read and write, which is basically activity coming in from the host, is fairly high. And I've also seen that the outbound copy rate is fairly high. So what's happening for the most part is I've got a lot of activity occurring from the host, as well as additional activity going on from a copy or replication perspective. And those are the things that are driving the utilization at that particular peak. If I want to go one step further, let me go to the CPU utilization and actually click on the peak. And one of the things I want to look at, let me go to clusters. I can actually see the mounts at the time. Now this is the part that I wanted you to pay special attention to, because we are now going from a physical, which is the TS7700, into a logical view, which is these are the mounts occurring at the time, plus or minus 30 minutes within this particular interval. So this is the actual workload that's running in that TS7700 cluster at this particular point in time, plus or minus 30 minutes. As you can see, you've got the vol ID, the system it's running on, the unit that it's actually allocated, the type of media, the job and program that was running, data set names, whether read or write activity, whether it's a specific or scratch mount, etc. So we are listing all the specific detail of the workload going on at that particular moment in time. Our feedback from initial customers from this particular function is that this particular activity could take them almost weeks to be able to do, and we're capable of doing it very quickly in the product in a matter of minutes. Operational benefits of being able to go from the physical to the logical, certainly we're showing you expertise. The software knows that there was an issue. It's highlighting and providing you ratings concerning the thresholds being exceeded in a variety of different dashboards. It gives you visibility to say it's pretty easy to assess, how busy the CPU is, when it's more busy than others, where you might be able to move scheduling activity if that's actually an option to try to avoid the CPU upgrade or hardware upgrade. And it gives you certainly the drill down capability so you can identify the ZOS workload that was active around the time of the event. So we're giving you the ability to hopefully identify and fix the problem.